Good morning, students.
Good morning, sir.
Okay. So in the last lecture, we have talked about the standing waves, then voltage standing wave ratio. All right. So we have seen that when there is no reflected wave, in that case, gamma is equal to 0. That is one thing we have seen. And voltage and current on the line, it consists of a superposition of incident and reflected waves, and these waves are called standing waves. Then we have also seen that when ZL is equal to Z0, that means when the load impedance is equal to the characteristic impedance of the line, then we say that this load is matched to the line. All right. Then we found out the relation for VSWR, which is given by V maximum upon V minimum, and that comes out to be 1 plus gamma upon 1 minus gamma, right? And we have seen that this VSWR, it is a real number, and when the load is matched, that means when ZL is equal to Z0, then VSWR is equal to 1. Okay. So up to this point we have seen, and then we have also seen that if we want to find this reflection coefficient gamma at some point L on the transmission line, then this gamma L is equal to gamma 0 e to the power minus 2j beta L. Up to this point we have seen. Now today we'll see about these standing waves and standing wave patterns on transmission lines. So okay, so today we'll see this. Now what are standing waves? Standing waves are created by the superposition of incident and reflected traveling waves. हमने आपको बताया था कि जब वेव ट्रेवल करती है along the transmission line, and यदि मान लीजिए वहां पर चाहे ओपन सर्किट हो, चाहे क्लोज सर्किट हो, और चाहे आपका लोड लगा हुआ हो, there will be a reflection, and that will depend upon the impedance which is present there. Well, right. So the waves are we get these waves, reflected waves, in an improperly terminated transmission line. Improperly terminated का मतलब when ZL is not equal to Z0, right? So by improper termination, what is meant, ये हमने लिखा हुआ है यहाँ पे, is that the load impedance has a value different from that of the characteristic impedance of the line. अब चलिए थोड़ी सी चीजें रिवाइज करते हुए हम कुछ और चीजें देखते हैं, और आज कुछ एनिमेशन भी देखेंगे जिसमें कि किस तरह से ये जो वेव्स हैं ये रिफ्लेक्ट होती हैं और कैसे स्टैंडिंग वेव्स बनाती हैं. So let us see that. Now this signal energy that is transmitted through a transmission line from the source or generator, ठीक है ना? So if you take a transmission line, and let us connect a source here in the transmission line, and here we have a load ZL. Okay, so signal energy from your source that is transmitted along this transmission line from the source or generator to the load, right? Here this load is there, so it is transmitted through the transmission line to the load or receiver in the form of voltage and current waves. All right. अब क्या होता है कि at the load end part of the signal that is reflected back, है, देखेंगे अभी, अब आपको एनिमेशन भी दिखाएंगे। पार्ट ऑफ द सिग्नल दैट इज रिफ्लेक्टेड बैक डिपेंडिंग अपॉन द टाइप ऑफ द लोड इंपेडेंस ZL। तो यदि कैरेक्टरिस्टिक इंपेडेंस Z0 इज इक्वल टू ZL होगा तब तो कुछ भी रिफ्लेक्ट नहीं होगा, और Z0 और ZL में डिफरेंस होगा तो इट विल डिपेंड कि कितना सिग्नल वहां से रिफ्लेक्ट बैक होता है, ठीक है ना। And this ratio of ZL and Z0 that determines your reflection coefficient gamma L that we have seen at the load end. So reflection coefficient, it assumes different values, right? As one transfers the reflection coefficient, it assumes different values as we travel down the line from the load end towards the source. Okay. Now हमने लिया था कि V0 plus and V0 minus, they are the amplitudes of the incident and reflected waves in a transmission line. So this we have taken V0 plus and V0 minus. These are the amplitudes of the incident and reflected voltage wave in the transmission line, and length अपन ने ली थी L, मान लीजिए यहाँ पे suppose this length of the transmission line, that is L, right? And propagation constant gamma, that is equal to alpha plus j beta. This also we have taken. What is alpha? Alpha is the attenuation constant and beta is the phase constant of the line. All right. So अब अपन चाहते हैं कि reflection coefficient at any point Z from the sending end, ठीक है ना, और at any point D from the load end. तो यहां से यदि मान लीजिए अपन इसको यूं ले लें, कोई भी पॉइंट यहां ले लें, यहां से this is D and suppose this point from here it is Z. All right, then we can write D is equal to D, that will become L minus Z. Okay, and this reflection coefficient which we have defined earlier, we can write as at the point Z. Right? All right, at this point we are talking, so we can write this as gamma Z. Suppose at this point gamma Z, we can write this as V0 minus e to the power plus gamma Z divided by V0 plus e to the power minus gamma Z. This is the incident wave नीचे है और ऊपर जो है वो रिफ्लेक्टेड है, ठीक है ना। एंड देयरफॉर गामा D के रूप में यदि अपन लिखना चाहें, gamma D instead of Z. So if you want to write this, then what we will do? We will write for Z L minus D. So this becomes V0 minus e to the power plus gamma into L minus D divided by V0 plus into e to the power minus gamma into L minus D. All right. और इसको थोड़ा सा और सॉल्व करें तो ये हो जाएगा आपका, दिस विल बी इक्वल टू V0 minus e to the power plus gamma L divided by V0 plus e to the power minus gamma L into e to the power minus 2 gamma T. Okay, and this we can write as equal to some gamma L e to the power minus 2 gamma D, where gamma L, that is your V0 minus e to the power plus gamma L divided by V0 plus e to the power minus gamma L. इसके लिए अपन ने gamma L लिख दिया, and this we can also write as, now ये जो equation हमारा आया gamma D, this we can also write as mod of gamma L, जैसे अपन ने पहले किया था, e to the power j theta L मान लें, e to the power minus 2 gamma D. Alright, तो अब यहां पर gamma L क्या हो गया, that is also equal to, this is also equal to mod of gamma L e to the power j theta L. ठीक है ना, and mod gamma L, what is mod gamma L? That is the magnitude, right? Mod gamma L is the magnitude, and it is never greater than unity. That means mod gamma L is always less than or equal to 1. So mod of gamma L is always less than or equal to 1. Alright, theta L क्या है? Theta L is the phase angle between the incident and reflected waves. This theta L, that is the phase angle between incident and reflected waves. All right, mod gamma L is the amplitude, this is the phase angle, and it is also called the phase angle of the reflection coefficient. Phase angle of the reflection coefficient, right? So this is also called the phase angle of the reflection coefficient. ठीक है, now standing wave के लिए अब कैसे मिल रही है अपने को? That is because of the superposition of the incident and reflected voltage waves, right? So for that we can also write in this manner the expression as we can write here as V standing wave, all right, SW, VSW, that is equal to V incident plus V reflected. Okay, so that will be equal to incident wave V0 plus e to the power minus gamma Z plus V reflected, that will be V0 minus e to the power plus gamma Z. Okay, and this we can write as V0 e to the power V0 plus e to the power minus gamma Z into 1 plus V0 minus e to the power gamma Z divided by V0 plus e to the power minus gamma Z. All right, so this will become V0 plus e to the power minus gamma Z into 1 plus gamma Z. All right, so now if we'll see the standing waves with time, है ना, तो अपन देखेंगे कि ये जो एम्पलीट्यूड है VSW, मॉड VSW यदि अपन ले लें एम्पलीट्यूड को, सो वी कैन राइट हियर VSW amplitude. Let us write this as mod of VSW. Okay, so if we see this amplitude of the standing wave, है ना, मैं बात कर रहा हूं स्टैंडिंग वेव के एम्पलीट्यूड की, ध्यान रखें। तो स्टैंडिंग वेव जो बन रही है, यदि इसके एम्पलीट्यूड की बात करें तो अब आप यहां देख रहे हो कि ये जो एम्पलीट्यूड है, ऑल राइट, this one, okay, this is also changing with z, e to the power minus gamma z hai, as it is progressing. So if we follow this standing wave with time, we will find that its amplitude also oscillates between a maximum value v maximum and v minimum, जो अपन ने निकाला था पिछले लेक्चर में, है ना, और हर लैम्डा बाय 4 पर ये चेंज होता है, ठीक है ना, राइट। सो द वेवलेंथ जो है वो भी अपन ने निकाली थी, लैम्डा दैट इज इक्वल टू वीपी अपॉन एफ, वेयर एफ इज द फ्रीक्वेंसी ऑफ द सिग्नल एंड वीपी इज द फेज। ये पूरा लिखने की जरूरत नहीं है, आपने सब देखा हुआ, फेज वेलोसिटी ऑफ द वेव, राइट, एंड दिस फेज वेलोसिटी ऑफ द वेव इज स्लाइटली लेस देन द वेलोसिटी ऑफ लाइट ऑफ द या वेलोसिटी ऑफ द इलेक्ट्रोमैग्नेटिक वेव इन स्पेस, ऑलराइट। और डिस्टेंस बिटवीन टू सक्सेसिव मैक्सिमा, ये भी हमने बात की थी, दैट इज लैम्डा बाय 2, और टू सक्सेसिव मिनिमा इज आल्सो लैम्डा बाय 2, ठीक है ना। एंड नाउ लेट अस सी दिस स्टैंडिंग वेव हाउ इट इज formed. So this is the screenshot of the incident and reflected standing waves and the standing wave pattern for a lossy line, जहां पे लॉस हो रहे हैं। तो आप यहां देखोगे कि ये जो है इस जगह पे ये जो पॉइंट है, ये जो पॉइंट आप देख रहे हैं मैक्सिमा के पॉइंट, यदि अपन लें, जो इंसिडेंट वेव है, रेड से कौन सी वेव शो हो रही है, दैट इज ए इंसिडेंट वेव, दैट इज ए फॉरवर्ड वेव, ट्रेवलिंग वेव। तो आप देखेंगे कि ये जो एम्पलीट्यूड से कम होते जा रहे हैं, इधर नजर आ रहा है सबको?
यस सर।
राइट। और ये जो दूसरी लाइन दिख रही है आपको ब्लैक में, है ना, तो इसमें आप देखेंगे ये रिफ्लेक्टेड वेव है, ठीक है ना, राइट, दिस इज रिफ्लेक्टेड वेव, सो इट्स एम्पलीट्यूड इज आल्सो चेंजिंग, यहां ज्यादा है और ये कम होती जा रही है इस तरफ, ठीक है। सो दिस इज ए स्क्रीनशॉट एंड नाउ आई विल शो यू द एनिमेशन फॉर दिस। सो लेट अस सी द एनिमेशन।
how we can form a standing wave by disturbing a string so that a continuous traveling wave travels towards a fixed boundary and reflects and interferes with itself, really. So the reflected wave interferes with a wave that's still incident on the boundary. Let's have a look at what that looks like. So here we can see we're creating a continuous up and down disturbance on the left end of the string, which causes a continuous traveling wave, which is the red wave here, to travel towards this boundary. And so this wave is represented by the red wave. What's going to happen at the boundary is we're going to get an inversion of the wave and reflection. We're going to have that represented by a blue wave traveling back in the opposite direction. So I'll just slow this down while it's happening. So here we can see the first wave, part of the wave is just about to arrive at the boundary, and it reflects and inverts, and the reflected wave interferes with the incident wave that's still arriving at the boundary. And that interference results in a kind of cancellation of parts of the wave, so they're interfering as per the principle of superposition. And we'll just speed the animation up again. And what we can see is as the returning wave, the reflected wave, interferes with the incident wave, we have the conditions required for a standing wave to be set up. And you can see that we get this pattern of stationary nodes and antinodes along the wave. And we have a standing wave, which is this black wave, which is just the superposition of the two waves of equal amplitude and equal frequency traveling in opposite directions. And because of the phase change that happens at the boundary, we always end up with a node at the fixed boundary. So that's a boundary condition for a standing wave on a string. If we have a fixed boundary, the two waves
Okay, so this is all.